Okay, so we have a particle moving accordingly to this law between 0 and pi seconds. Find the expression for the velocity and acceleration. Velocity ds by dt, acceleration d2s by dt squared. So s equal k sine squared t, velocity ds by dt equal k times sine squared t. The same as sine t squared, so 2 sine t times the derivative of sine t. So it's 2k sine t cos t. So that's the velocity. Acceleration is d2s by dt squared. So 2k, and now sine t cos t, we differentiate it within the product rule. So the product rule, the derivative of sine t is cos t times cos t, plus sine t times the derivative of cos t, which is minus sine t. So we get 2k cos squared t minus sine squared t. And it's in the acceleration. I can write a of t because acceleration depends on t, velocity depends on t as well. Next question asks, find when velocity is 0. And question C, find when velocity is maximum. So this is the same as acceleration being 0. V of t, we decided this 2k sine t cos t. Question B, V of t equals 0. So 2k sine t cos t equals 0, meaning that either sine t is 0 or cos t equals 0 or cos t equals 0. So t can be, so sine t is 0 at 0 and pi, cos t is 0 is pi over 2. I think t was between 0 and pi included. Let us check. Yes, correct. Now, velocity is maximum or minimum when acceleration is 0. So, cos squared t minus sine squared t is 0. Therefore, cos t equals plus or minus sine t. I think the best to represent this is on the unit circle. Cos t is the x-axis, sine t is y-axis. Cos t equals sine t when they are both on the line y equals x, and cos t equals minus t when they are on the line y equals minus x. One solution is here and one solution is here. So t is either pi over 4 in the first quadrant or 3 pi over 4 in the second quadrant. Now they ask me when the acceleration is at maximum. Okay, so in order for the acceleration, for the velocity to be at maximum, I want velocity at maximum, so acceleration pi over 4 is 0, 3 pi over 4 is 0. I will need to check for a point before and after pi over 4, for a point before and after 3 pi over 4, and see the signs here so that I can decide if a function increases and decreases. I let you with this.